Now we're going to look at equations of lines. So you can write an equation of a line if you're given any one of the following pieces of information: slope and y-intercept, slope and the coordinate points, coordinates of a point on the line, or the coordinates of 2 points that are on the line. So if m is the slope of the line, b is its y-intercept, and x1, y1 is a point on the line, then we have a couple of different forms of the equation of the line that we could write. We've got slope-intercept form here, which is y equals mx plus b. And we've got point-slope form, which is y minus y1 equals m times x minus x1. Now for a few examples here, we're going to write an equation in slope-intercept form of the line with a slope of -2 and a y-intercept of 4. Now, since we have the slope and the y-intercept, we're going to be using this form of the line, y equals mx plus b. The slope is -2, m is -2, and b is +4 from the given information there. So we just have to substitute those into the appropriate places in this equation. So the equation of the line that's described here would just be y equals -2x plus 4. So now we have a couple of guided practice problems here. This would be a good place to pause the video and try these, and then come back and see how you did. So for the first one here, we are supposed to write the equation in slope-intercept form. So slope-intercept form is the y equals mx plus b form. So that means in order to do that, I'm going to need to know what m is and what b is. So taking my first bit of information here, they tell me that m is 2 and b is -3. So since they gave me m and b already, I just need to substitute those into the equation. So y equals 2x minus 3. Now it also asks me to graph the line, so I'm going to do that as well. I'm going to start with that y-intercept at -3. That's where it crosses the y-axis. And then I'll use the slope to find additional points that are on the line. So from here, my slope is 2, so that's a rise of 2, up 2, and a run of 1. That's to the right 1. That would give me another point. Then I could do that repeatedly to find more points. So up 2 over 1. I could do that all the way across the plane here. That'll give me a little bit nicer line when I try to connect them. So now I'm going to go ahead and connect my dots. Yeah. Okay, for my second guided practice problem here, I've got a point 0, 3 and another point -2, -1. Now 0, 3 is actually a y-intercept. So this is actually giving me my b value. If I were to plot it, it would be right there. I'm going to go ahead and plot the other line, the other point also. -2, -1 would be right here. And I could actually graph the line really easily on this one because I can just connect these two dots. Points. I shouldn't call them dots, they're points. All right, so if I'm trying to fill in y equals mx plus b, I have the b value. They gave that to me, so I could put in +3. So all I need is the m value. So I'm going to go back and use my points and my slope formula in order to fill in that m. So the slope formula says the change in y, so y2 minus y1, so -1 minus 3, over x2 minus x1, so that would be -2 minus 0. Then I just need to simplify. So -1 minus 3 is -4, -2 minus 0 is -2, and a -4 divided by -2 would be a +2. So this would be a +2. So my equation of the line described here is y equals 2x plus 3. Okay, so now we're going to write an equation of a point in point slope form of a line. And this time they're giving me that the slope is -3/4, and the line is going to contain the point 8, 1. So since they gave me a point and the slope, I'm definitely going to use point slope form. They also asked for it in point slope form. And this one is our point slope form. Y minus y1 equals m times x minus x1. Now when you're doing this, you're filling in the x and the y value from the point that you're given, and you're filling in the slope, but the y and the x with no subscripts on them, those are your variables in the equation. So those are not going to be replaced with numbers. All we have to do is fill in y1 is 1, x1 is 8, and m is negative 3/4. So I fill those in the appropriate places. And that gives me the point slope form. I don't even have to do anything to it. Okay, so again, we've got a couple of guided practice problems here. So this would be a good place to pause the video and try these and then come back and see how you did. All right, so they gave us the slope and a point. So I'm just going to be filling in the appropriate places in my point slope form. So I'm going to go ahead and write down everything and leave blanks for the things that I need to fill in. So y minus blank equals, oops, that's supposed to be a blank as well. All right, y minus blank equals blank times x minus blank. And I just have to go back and fill in the blanks. So m is what goes here in front of the parentheses. So I'm just going to fill in 1/2 there. This over here is supposed to be y1. So that would be the y from the point that's given. A y minus a negative 2 would be the same as y plus 2. So I'm just going to change that to y plus 2. And then over here, I need the x value from the point that's given. So that would be x minus negative 3. So I would write that as x plus 3. This is the form of the line that they asked me to write, so I'm not going to change it. They do also want me to graph this line, so I'm going to graph it using the information that they gave me here. So the point that I have is negative 3, negative 2. So I'm going to start there. Left 3, down 2, put a point. And then I'll use the slope to find additional points. So this is vertical change, this is horizontal change. So from this point, I need to do a vertical change +1, horizontal change +2. Put a new point there. And I'll do that a few times just to make my line, make it easier to hit all of the right points. My line will come out looking a little better. And then we'll connect the dots. Okay, for the second one on here, the slope is -2. The point that they gave me is 3, -1. So they want it in point slope form. So again, I'm going to write that one down, leaving blanks for all the things that I need to fill in. So y minus blank equals blank. And then in parentheses, x minus blank. And then we'll fill in the blanks. So the m is the number that goes in front of the parentheses. The number that belongs over here is the y value for my point. So this would say y minus -1. So I'll write that as y plus 1. And the number that belongs over here is the x value from the point that I have. So this would be a 3. This is the equation of the line. And again, I want to graph it. I'm going to use the given information to do that. So I'm going to start at my given point. So 3, 1 is, oops, it's 3, -1. So 3, -1 is here. And then my slope from there is -2. So to turn that into a fraction, I just put a 1 in the denominator. So that means my vertical change is -2, so down 2 from here. And the horizontal change is a +1. And I'll do that a couple of times. I can also go the other direction by changing the negative to the denominator. So that would make the vertical change +2 and the horizontal change -1, just like yesterday. Alrighty, this one came out nice on your notes, but for some reason it didn't come out real nice on mine. So you'll need to look at your copy for this one. The equation of a horizontal line is y equals whatever number is the y value for any point that's on the line. If you think about a horizontal line, all of the y's are the same on this horizontal line, no matter which point you pick. The x's are all different, like maybe this one's a -3. I guess let's put in a coordinate plane here. I'll say it looks like the y value is maybe about a 4. So this would be -3, 4, and this one over here would be maybe 1, 4. And if I picked another point over here someplace, well, truth be told, I don't really know what the x is, but I would know for sure that the y is 4. So writing y equals 4 would be a great way to describe every point that's on this line. For a vertical line, similarly, all of the points on a vertical line have the same x value. So I'm going to use a little bit of a line that I can see from the picture on here for this one. So let's see, the x value on this one, this is my y-axis. So that means it's 2 to the left here. So if I choose this point right here, I know for sure that the x value is -2. I'm not sure what the y value is because I can't see the x-axis on mine. You can see it on yours, so you can probably figure it out. But I'm going to guess it's about a 4. If I picked another point, like say this one right here, well, the x value would still be -2. That's interesting. Well, let me write there. Okay, so the x value is -2, and the y value would be +2. So you notice that the x values stay the same. They're both -2 there. So a good way to describe this line is just x equals -2. Vertical line is always x equals, and then whatever the x value is for all of the points on the line. Alrighty, for our next example, we're going to write an equation of a line that passes through these 2 points, -3, -2, and -3, 4. Now, the first thing that jumps out at me about this is that I see the x value is the same for both of these points. So if you're not sure what that means, you could draw yourself a quick little sketch of those 2 points just to see how they're related. So my first point is -3, -2. So that would be about right there. My second point is -3, +4. So that would be about right there. And if I were to connect them, then it becomes very clear that I'm dealing with a vertical line here. I missed that point, but we got the idea. So this is a vertical line. Now, to figure out which way you're supposed to write the equation, you need to think about what's the same on this line. For every single point that's on the line, the x's are all the same value. So when I write the equation of that line, I would write it as x equals -3. Well, let's go back and look. You can also get that from the points. It's the x value on both of the points is the same. So x equals is the right way to state it. Okay, last example for today. We're going to write an equation in slope-intercept form for a line that is perpendicular to that one and contains the point -4, -3. And then we're going to graph both lines. So since we have to graph the lines anyway, I want to go ahead and graph this one. I think I'll do this one in pink. All right, so this one's going to be pink. Now to graph this one from the line, I'm going to use the slope and the y-intercept. So the y-intercept is the number that's added here on the end, and that's where I'm going to start. So I'm going to start at 5 on the y-axis. Then the slope tells me how I can find another point that's on that line, another nice point. So this says vertical change 1, horizontal change 2. So from here, I go up 1 and to the right 2. And then again, I can do that a bunch of times. I'm also going to go down 1 and left 2. You note that it follows the same pattern there. The points line up with the rest of the pattern that we saw. And I'm just doing that so that I have more to shoot for because I have to freehand this. As I mentioned in a previous video, if I were doing this on paper, I would be using a straight edge to make my lines just right. Okay, now for my other one, I think I'll use blue. So this one says the point that it's supposed to contain is -4, -3, and it's supposed to be perpendicular to this line here. So what is the relationship between perpendicular lines? Well, that relationship is that the slope is going to be the opposite reciprocal of the one that was given here. So the opposite reciprocal of 1/2 would be negative, since 1/2 is positive, and then the reciprocal of 1/2 is 2. So the slope would be -2 on this one. So I'm going to write the equation for this one. They asked me for the equation in slope-intercept form, but since I wrote that wrong. Since I have a point and the slope to work with, I'm actually going to start this one with point slope form, and then we'll manipulate it algebraically. So I'm going to say y minus blank equals blank, and then parentheses x minus blank, and then we're just filling in the blanks. So my slope goes here in front of the parentheses. This blank over here is the y value from the point. So y minus the -3 would make it say y plus 3. This blank over here is the x value for my given point. So that would be x minus -4, which would be the same as x plus 4. I'm going to go ahead and graph it from here because graphing from the point and the slope is pretty easy. So -4, -3, 2, 3, 4, 1, 2, 3, here we go. And then the slope is -2. So that means from here, I would need to have a vertical change of -2 and a horizontal change of 1. And then I could do that repeatedly till I run out of graph to work on here. So now I'm going to go the opposite direction. So I'm going to go up 2 and to the left 1. Up 2, left 1. Up 2, left 1. Keeping in mind that the points are supposed to continue to fall in the same path here, the same pattern. Once I have a bunch of points, I'll connect them, putting arrows on the end of either side of the line. And just at a glance, it does look like these lines cross at 90-degree angles, which is what we were supposed to be having happen. We were supposed to have perpendicular lines. They do look perpendicular at a glance. Sometimes you can have lines that are actually perpendicular and they don't look perpendicular at all because the scale is different on your x and your y axis. This time our scale is the same on either axis, and so everything's square. It looks very nice. Okay, so now I need to manipulate this because the form that they want, slope-intercept form, is this one here, y equals mx plus b. So now for this manipulation, to make it look like this, essentially, I have to get rid of the parentheses and get the y by itself. So I'm going to start with getting rid of the parentheses by distributing that -2. So I'm using the distributive property. That would be negative 2x minus 8 there. Now that I've gotten rid of the parentheses, my next job is to get rid of the number that's over here with the y. So for that, I'm going to use the subtraction property of equality. I'm subtracting 3 from both sides of the equation. On the left, the plus 3 and the minus 3 cancel each other out, so it leaves just y. That's using the substitution property. And over on this side, the minus 8 and the minus 3 can be combined. Negative 8 minus 3 would be negative 11. And once again, that's using the substitution property. This is now in slope-intercept form. And if I compare it with what I have for my line over here, this blue line, this would mean that the y-intercept is negative 11. At a glance, it looks like that's a reasonable value for that. The slope is the negative 2, so it does have a negative slope, so that means it should be trending downward from left to right, and it is. So I'm going to call this a win.